One observation that I've made repeatedly, both inside and outside the classroom, is how often people say things like, I don't like science, I'm not good at science, I'm not smart enough to do science, I hated my science classes in school. This isn't just a random observation that I've made either. Non-science majors at universities don't feel like science people, they aren't motivated to engage with science, and they fail to see the relevance of science to their own lives. And then when we look at the general public, we witness the mistrust of scientists and scientific information. In fact, you might be in this course because you're looking for new ways to reach the general public. So far in this course, we've learned about more traditional avenues of science communication through oral and written means. In the last module, we learned about gamings and other forms of educational technology to communicate and to teach science. In this final module, we're going to look at the arts for science communication. Why the arts? How can music or photography or graphic design help communicate science? The arts are a very powerful form of science communication for two reasons. First, a good drawing or infographic can quickly and effectively communicate an idea. Here's an example. This drawing quickly and accessibly introduces the common phrase, doing your own research, with the cognitive phenomenon of confirmation bias, something that we talked about in Module 1. Keep in mind that infographics can also be a great way of communicating science to other scientists as well. This is a line item that scientists are starting to include in their grants as part of disseminating their findings. Biological illustration plays an important role, not just in science communication to the general public, but also within professional communities and science education. For example, lacking a time machine, the only way to visualize lifelike reconstructions of extinct organisms is to generate illustrations or animations. This involves someone's ability to use scientific evidence at hand, such as fossils, and creativity to express what something may have looked like. Certain molecular phenomena are not directly visible. All we can do to see what's happening is to look indirectly, like looking at bands on a gel to see if a certain form of a protein is present. An artist can turn this information into an illustration or animation that is more accessible to science students. Think of the textbooks that you may have used in school. They are full of high-quality illustrations. Now, if you've been in school more recently, many electronic textbooks are also coming with a host of animations as well. Illustrations can also be used to remove distracting or unnecessary aspects that would be found in an actual image. This is important when we consider human cognition as well. Our brains can only handle so much information at once, and reducing what's called cognitive load is important for facilitating teaching. So, for example, if we're looking at an image of a dissected human body, it's very easy to get distracted by everything that we see. But a beautiful illustration of a single structure without any intervening blood or viscera helps the student focus on the most important part. We see this concept applied outside of biology as well. Think of roadmaps. They are simplified versions of rich structures. However, most of that extra information is removed so that we can focus on how to get from point A to point B. Illustrations and animations aren't only important in education. Researchers and professionals like doctors use them to communicate important findings. Now, our second reason for why the arts is a powerful message of science communication is that the arts can serve as a bridge and a valuable way of reaching people who aren't confident in their ability to engage with science. The arts in any form can create an emotional response. We get chills listening to music, or find ourselves pondering photographs or images, or decorating our workplaces with art. Disliking science, having negative emotions pop up when we think about science, remembering bad experiences in school, these are all emotional responses as well. And emotional responses that keep people from re-engaging with science in their own lives. But it can also go the other way too. Tapping into positive emotions through the arts can help people begin to re-engage. Here's an example in conservation. Photography is a way of helping to both document life on Earth and foster a sense of connection between humans and endangered or threatened species. This is the root of Joel Sartorius' work on the National Geographic Photo Arc. Sartorius spent the last 10 years taking studio portraits of animals, many of whom are endangered or threatened as well. He does this to get people to care about living beings that they may have never heard of before. I have two Sartorius books. This one is rare. It's about endangered species that we find in America. And so you can look through and see in the individual pages and a little bit of information about each of these animals. So for example, that there's only 586 Wyoming toads left as of the publication of this book. I also have his children's book. It's got pictures as well as poems in there. So again, you can see these images and also some of the damage from my son reading this book. And it's about helping children build a sense of connection with these animals so that they care about them. Sartorius has been quoted as saying, "You won't say what you don't love." And the photos are designed to build a sense of connection to spur conservation. Too often, science is portrayed as one-dimensional, boring, and abstract. And art is an excellent way of building that gap and communicating key ideas to a larger audience in a more relatable and accessible fashion. How else do we see biology in the arts interface? Another consideration is how art and science are inextricably connected with one another, which we'll explore in more detail in the next lecture video.